We talked about the difference of matter and energy. We talked about how there are different types of energy, potential and kinetic, right? And then we ended by looking at this example of how energy, it's not destroyed, it actually is transformed into different types, like we see in the television, right? So television started with chemical potential energy, that was transformed into electrical energy, and then we turn the TV on, we get sound, light, thermal, mechanical energy, all happening in the TV. And then we ended with this idea that if we were to add up the total amount of energy that's transformed by the TV and compare it to the total energy used by the fossil fuels, it should be equal. Because we're not destroying energy, we're changing its form as it moves through matter. So what I want to do is I want to talk about how this is related to biology and how this is related to ecosystems in particular. So in an ecosystem, this is what we'll start up today. It said that, what's that?
You rate that?
Yes. So we're picking up where we left off. Thank you, Brian. So in an ecosystem, it said that energy flows. So energy flows through an ecosystem, and the way that we represent this is something that you've seen before. We use a pyramid. So this pyramid has a couple different levels. At the very bottom, we have producers. The next level, we have primary consumers. And then we've got secondary consumers. And tertiary consumers. So what this pyramid is representing is how energy is actually flowing through an ecosystem. So it's known that the source of all the energy that flows through an ecosystem is the sun. And the sun provides solar or light energy to an ecosystem. The purpose of a producer is to capture that solar energy and store it as chemical energy. So producers, they capture solar energy and store as chemical energy. Does anybody know what we call that process of capturing energy from the sun and storing? Photosynthesis, right? So photosynthesis, this is the process by which producers capture solar energy and they store it as chemical energy. Now, if you remember when we did our food webs and things from last unit, we drew arrows that indicated where the energy was flowing. As an animal eats, producers and secondary consumers eat the primary consumers, energy is passed to the next level. Energy is passed to the next level as animals are eaten. A quick note down here. So, energy is stored in the biomass of an ecosystem and is transferred between trophic levels. So biomass, that's just referring to that organic matter. If you think about what gives energy to the next level, it's their food, right? The food is what contains the energy, it stores the energy. Right? And that energy is transferred between trophic levels. Now, a trophic level, you might think of like a trophic cascade, but a trophic level, what this means, a trophic level is similar organisms in an ecosystem with the same amount of energy. So, trophic level, there are similar organisms in an ecosystem with the same amount of energy. In the case of this ecosystem, we have 1, 2, 3, 4 trophic levels. All right. So the reason I'm making this up is because as energy is transferred between trophic levels, it's actually known that approximately 10% of the energy from the previous level is transferred to the next level. So 10% of the energy in the producers is transferred to the primary consumers, and so on and so forth. Only 10% is transferred. So then what happens to the other 90%? There's 2 places where it goes. So 10% is transferred. One place that the rest of the 90% goes. Is energy is lost as heat energy. Energy is lost as heat energy. Yeah. And I'll pause for a moment if people catch up here. Okay. So 10% gets passed along at every stage. Energy is lost as heat. And then also, at every transition, there's actually energy that goes unused. There's energy that goes unused, and we call that waste, or detritus, another term. This is unused energy. So if you think about, like when a producer dies, when a tree dies, there's still energy contained in that biomass, but it wasn't used. And so it gets put into this category of waste. Now, some of this waste there is a particular type of organism that actually lives off of that unused energy in the waste. We call that a decomposer. Back table, am I going too fast? Are you good? Can you see okay? You're good? Okay. So a decomposer is something like a bacteria or a fungus that actually gets energy from waste. It'll decompose some of that unused energy and use it for itself. This also helps put nutrients back into the ecosystem. Those are decomposers. Even still, though, a lot of that waste doesn't get used by decomposers. It actually gets stored, bless you, underground for a long period of time. So this is happening all the time. We see a lot of this waste actually gets stored underground. If we're talking about millions of years here, this waste, unused energy actually gets stored underground, and due to pressure, as it's deeper and deeper into the ground, this is ultimately what gets used as fossil fuels. Right, fossil fuels being natural gas, coal, oil. This is a chemical potential energy. So it's kind of crazy is when we think about fossil fuels, the energy that's stored in a fossil fuel actually originated from the sun. So when we release the energy inside fossil fuels, that's actually energy that went unused, that originated from the sun, which is something I don't think we necessarily think about. That the energy in the sun is actually what's stored in fossil fuels. Okay. Are there any questions so far? I see a couple people still writing, so I'll pause for a moment. All right. So to close this up, I want you to turn to your neighbor. I want you to think about this question. So let's take natural gas, for example. So natural gas, something you put in your car. When you burn natural gas by adding thermal energy, that thermal energy rearranges the gas that leads to the release of the potential energy inside the gas. When we do that, it produces pollution, right? Carbon dioxide, a couple other different types of pollutants. Turn to your neighbor. Is pollution, will we classify pollution as being matter or pollution as being energy? Turn to your neighbor real quick. Is pollution matter or is pollution energy? Is pollution matter or energy?